Yesterday we looked at bivariate data, and today we're still going to do exactly the same questions. We're just going to show you how to use our calculators to find this data, all right? So we're doing very similar to univariate data, but this time we're doing bivariate data. So we once again go into statistics. So all of this is in statistics. And then we put our two sets of data into list 1 and list 2. So it's a bit like a frequency table. Sorry, wrong one. All right, so statistics, and then we put in our data. Just clear all. All right, so we'll just start with something pretty simple, and we'll just say just test scores again, I guess. Okay, so test 1, test 2, 50, 62, 51, 63, 55. Okay, so we'll just use those scores. So if we put those into our lists, so 50, 51, 55, 80, 91, 56. So you guys should either be writing this down or doing it on your calculator. Can you see how I made a mistake here? You can't then, so I forgot to press enter. You can't then sort of go backwards and sort of edit in. So you actually need to redo it. So click in here, 63, 65, 73, 87, 63. Okay, so you should have your data in. When you've got those numbers in, we need to just make sure we change our settings. So last time we went set graph settings, set graph, setting, and we changed this to histogram. What sort of graph do we do for bivariate data? Scatter. So we leave it and we say, okay, our X list is list 1, our Y list is list 2. So we're saying X is list 1, Y is list 2. And so we can pretty much just check that and go, yeah, that's all right. So we just click OK. Okay, so set graph, setting, that's all good. So scatter, list 1, list 2, and then click OK. Okay, that's just telling our calculator we're looking at bivariate data, and the graph we want is a scatter plot. Sorry, it's not okay. It's click set, sorry. So you always have to start with that because you're telling your calculator what sort of data it is. If you don't tell it, it will assume it's bivariate, and then when you have univariate data, like your histogram stuff, it will do a scatter plot. How do you think we then actually graph it as a scatter plot? Click the top left button, the graphing button, okay? To graph. We click on that graphing button, and your graph should then come up with a scatter plot. Once we've got a scatter plot, what do we then have to always do to make predictions? Line of best fit. So we then need to be able to find a line of best fit. To draw a line of best fit, we need to go into our graph and we go calc linear reg. Linear reg stands for linear regression line, straight line regression line. Okay, so we go calc linear reg and click OK. Calc linear reg. Okay, and we don't have, and then we get this screen up here. This screen, excuse me, this screen tells us the equation of the line. So the equation of the linear regression line. What that means, I'll show you here, is that all right, it says y equals ax plus b. So it's not using m and c, but it's still the same thing. So a is the gradient, b is the y-intercept. So for this equation, the equation of the line of best fit is y equals 0.5417549 x plus the y-intercept is 34.25. It gives you the equation of the line of best fit. This is the equation of the line of best fit. Okay, the A comes from there, the B comes from there. Any questions? What do you think this R stands for? No? It's the correlation coefficient, which we talked about the other day. It means that 0.95, so 0.95 means it's a very strong positive linear relationship. Remember we talked about going from -1 to 0 to 1? 0.95 is really close to that perfect linear relationship where lines are all in a straight line. Okay, so that tells you the correlation coefficient, tells you that it's a strong relationship. You can talk about that later. Okay, and when I click OK on my calculator, it then puts a line in. Okay, that's our line of best fit, and that's where we get our predictions from. I don't know if people want to still write that. So our calculator now has a line of best fit. I will email you these notes. Is that easier for you? Yeah? All right. That's fine. So you've got your line of best fit here. What do we need to do once we've got a line of best fit? Make predictions. And how we make predictions is in our graph, we go analysis, trace, and then we write a number. So for example, we might say 68. When we write the number in, that screen comes up. So if I didn't write the number in, I'd go analysis, trace, and then it just has a dot there which is flashing. Okay, and you can sort of use your arrow to move it up and down. The arrow is not accurate enough. Okay, you can't use the arrow to find your answer. What you need to do is you need to actually write in the number. So we go analysis, trace, and then write in the number. It'll be an X value. do you want to make a prediction for? The box should come up when you start writing the number in. So on my calculator, I wrote analysis, trace. As soon as I write the number 6, analysis, trace. As soon as I write the number 6, this box comes up. It says X value. Okay, what X value do you have? We've got 68. And I click OK and I go, OK, 71. Rory, you're going to miss things. So this question here, I'd say, okay, what value would you predict a student would receive in test 2 if he received the following in test 1? And the first one I said was 68% for test 1. So I went analysis trace and it said when X is 68 on this line, Y is 71.09. For test 2. And that would be your prediction. I then might say if someone got 35% in test 1. Can I just get everyone's eyes up for a second for this one? If I do the same thing, so I go analysis, trace, 35. Let's just see what happens. I go, okay, it says domain. Why do you think it says domain? Any ideas? Yeah? It's not in the X values we've got. It's not in the graph we can see on our screen. We can only find answers in our calculator on what we can see on our screen. And your calculator only looks at interpolation. It only looks between the data set. So if I want to go outside the data set, I need to go, okay, let's zoom out, zoom out. See, I'm zoomed out a bit further so it goes to 21. So now I can go analysis, trace, 35, and click OK, and it gives me an answer, 35. I would expect that for test 2, I would get 53.21%. If you're asked about reliability of these, the first one, is it reliable or not reliable? It's reliable. Why? It's interpolation. It's within the data set. What about the second one? Not reliable because it's extrapolation. It's outside the data set. As soon as you see the word domain, come up, okay, you need to zoom out and know that it's extrapolation. So as soon as you have to zoom out from your calculator screen, you should know that it's extrapolation is less reliable because your calculator screen only looks at interpolation. It looks within the data set. That's it. You can get data from this as well. You can go calc 2 variable data and you can get your data for those 2 variables as well. But we don't really do that much with this. We only really do it with 1 variable data. And that's it.